Somewhere between 3 and 5, AI-generated bug reports land in the Linux kernel mailing list every single day now. Most of them are wrong. Some of them are confidently, elaborately wrong. And the people who actually maintain the kernel, unpaid volunteers and a handful of corporate-sponsored engineers, have to read every one of them, triage them, respond to them, and then watch the same hallucinated issue get filed again 2 weeks later by a different model running the same bad prompt. That's not a vibe complaint. That's a real operational tax that just produced a real operational decision. The Linux kernel is removing entire subsystems and driver families to make the attack surface for noise smaller. The pull request in question targets the ISDN subsystem and a collection of old networking drivers. ISDN, if you're under 40, is Integrated Services Digital Network, a circuit-switched telephone technology from the 80s and 90s that was briefly the fast internet before DSL killed it. It has been effectively dead in production for years. The drivers that talk to ISDN hardware have been sitting in the kernel tree mostly untouched, not because anyone uses them, but because removing code from the Linux kernel is historically treated as a last resort. The kernel community has a strong bias toward keeping things around. Removing something means someone, somewhere, might break. That conservatism is usually a feature. The fact that they are overriding it now tells you something about how bad the noise problem has gotten. The maintainers are being direct about the reasoning. These old subsystems, ISDN, some of the ancient network drivers, are generating a disproportionate share of inbound bug reports from AI tools. The tools are doing what LLM-based code analysis tools do. They scan a codebase, find patterns that look like bugs according to their training data, and file reports. They are not running the code. They are not checking whether the hardware exists. They are not checking whether the code path is reachable in any real configuration. They are pattern matching against a corpus and generating plausible sounding issues. For modern, actively used kernel code, that's annoying but manageable because real bugs also come in and the signal-to-noise ratio stays workable. For a 30-year-old ISDN driver that nobody has touched since 2019, the ratio collapses. There are no real bugs coming in because there are no real users. There are only AI-generated reports about theoretical issues in code that runs on hardware you cannot buy. So the calculus flipped. Keeping dead code in the tree now has a maintenance cost that didn't exist 3 years ago. You're paying human attention to defend code that serves nobody. Removing it eliminates that cost entirely. If you're not in the tree, the automated scanners have nothing to scan, and the mailing list gets quieter. Let's be precise about what's actually in this pull request, because the reporting has been a bit loose. The ISDN subsystem removal is the headline item. That's the whole subsystem, not just some drivers. There are also specific old networking drivers being culled. The Fornix reporting references this as part of what would land in Linux 7.1, though the exact version targeting is still moving. This is an initial pull request, which means it's been submitted for consideration, but hasn't merged to Linux's tree yet as of the time this was recorded. The ISDN code alone is something like 100,000 lines, depending on how you count headers and makefiles. That's not a trivial deletion, and it's going through the normal review process. What's new here versus the usual kernel housekeeping? Kernel developers periodically remove orphan drivers. That happens. What's different this time is the stated reason. The commit messages and the surrounding mailing list discussion are explicit. AI-generated noise is a factor in prioritizing what gets removed. That's the kernel community making a policy response to an external pressure that didn't exist in the previous decade. That's worth paying attention to because it's a precedent, not just a one-time cleanup. There's a broader pattern here that your team should think about if you're running any kind of open-source project or operating an issue tracker. The marginal cost of filing a bug report just dropped to nearly zero for anyone running an LLM-based code scanner. GitHub Copilot, various security scanning tools, and a bunch of smaller players all have features that will automatically open issues or pull requests. Some of them are well-calibrated. Many of them are not, especially when pointed at legacy code. The Linux kernel mailing list is an extreme case because it's high-profile, it's all plain text, and it's easy to scrape and feed into a model. But the dynamic is not unique to the kernel. If you run an open-source library, or even an internal monorepo with a public issue tracker, you may already be seeing this. If you're not yet, you probably will be. The response options are limited and none of them are great. You can add friction to issue filing, requiring more structured templates, requiring reproduction steps, requiring a minimum account age on GitHub. That helps with naive automation but doesn't stop a well-prompted model. You can try to detect and close AI-generated reports automatically, which is its own arms race and introduces false positives. You can do what the kernel maintainers are doing. Reduce the surface area that generates noise by removing the code that attracts it. Or you can just accept the increased triage burden and staff accordingly, which for a volunteer-maintained project is not really an option. It's worth noting that the kernel community has been dealing with low-quality contributions for years. The University of Minnesota hypocrite commits incident in 2021 being the most visible example, where researchers submitted intentionally flawed patches to study the review process and ended up getting the entire university temporarily banned from contributing. The AI noise problem is different in character. Those were deliberate, adversarial, and targeted. This is ambient and accidental. Models are not trying to harm the kernel. They're just cheap to run, widely deployed, and pointed at public code because public code is there. The harm is a side effect of scale. One thing that's unclear from the reporting, whether the kernel maintainers have done any systematic analysis of which subsystems are generating the most noise, or whether the ISDN decision was more judgment-based. The mailing list discussions suggest it's largely qualitative. Maintainers know from experience which areas are attracting junk reports. A more rigorous approach would be to actually tag and track report sources, but that requires tooling and coordination that a volunteer project doesn't easily have. So they're making decisions based on pattern recognition, which is somewhat ironic given the problem they're solving. The real takeaway for anyone who maintains a codebase, open or closed: dead code now has a new carrying cost that didn't exist before. It's not just technical debt in the traditional sense, complexity, onboarding friction, test coverage gaps. It's also an AI report magnet. Unused code paths, deprecated APIs you kept around for compatibility, old platform support for hardware nobody runs anymore. All of that is now a surface that automated tools will scan, misunderstand, and report on. The kernel maintainers figured this out and acted on it. The action available to you right now is to go look at your own codebase and ask which parts of it are dead enough to remove, because the cost of keeping them just went up.